morning, students. Chapter 11, Thermal Properties of Matter. Today we will see some definitions, okay, some quantities related to substance, okay, whenever there is change in temperature. See, if you have object, okay, of mass m, and if you want to change its temperature by delta T, if you want to increase its temperature or if you want to decrease its temperature. If you want to increase its temperature, you have to supply energy, heat energy, okay, heat means this object will absorb heat, okay. If you want to decrease temperature, then this substance, it will reject heat, it will reject heat. So yes, this one is easy, okay. Whenever object, substance absorbs heat, its temperature increases. Whenever it rejects heat, its temperature decreases, okay. So now if you have one object of mass m, and if you want to change its temperature by delta T, then question is to change temperature by this given amount, what is amount of heat required? What is amount of heat required? Okay, so experiments were performed on different objects, okay. First object A of mass m, second object B of mass m, third object C of mass m. If we want same temperature difference, that is, I want to change temperature of this substance A having mass m by 20 degrees Celsius. Similarly, for this 20 degrees Celsius. Similarly, for this 20 degree Celsius. Okay, then amount of heat absorbed or rejected, it depends on this material. It depends on this material. Yes, it depends on this material. Okay. Also, if only for one object, for example, it is object A, substance A, I want to first of all increase its temperature by 20 degrees Celsius, then 40 degrees Celsius, then 60 degrees Celsius. Then for different change in its temperature, heat absorbed is also different. Yes, for object A, if I want to change its temperature by 20 degrees Celsius, there is some heat absorbed, let it is Q1. Then for change in temperature by 40 degrees Celsius, let heat absorbed or rejected is Q2. For 60 degrees Celsius, let it is Q3. Clear? Okay, so yes, from this all experiments we can say that yes, to change in temperature, by given amount, okay, heat required is important. For this, we will see different definitions. First, heat capacity. What is heat capacity? The change in temperature of substance when a given quantity of heat is absorbed or rejected by it is characterized by a quantity called heat capacity. What is heat capacity? Heat capacity S is equal to delta Q upon delta T. What is simple meaning of this? Simple meaning of this is, okay, if I give this Q energy, then change in temperature is delta T. If I am giving some energy, then what is change in temperature? Simple relation. Simple relation. Okay, for this amount of heat, it is temperature difference. For this amount of heat, it is temperature difference. Clear? Okay, so it is first definition, that is heat capacity. What is heat capacity? Okay, for given time, given temperature difference, what amount of heat is required. So again, what is definition? The change in temperature of substance when a given quantity of heat is absorbed or rejected by it is characterized by quantity called heat capacity. Heat capacity is defined as amount of heat absorbed or rejected per unit temperature. Okay, its unit is joule per kg. Its unit is joule per kg. Okay, yes, heat capacity for different material is different. Heat capacity for different material, for different substances is different. Okay, if you are taking, again I can say A, B and C, three objects. If I want to change the temperature by 1 unit, that is 1 degree Celsius, okay, then what is amount of heat required? That is called heat capacity. That is called heat capacity. Next one, specific heat capacity. Specific means what? It is defined as the amount of heat per unit mass absorbed or rejected by substance to change its temperature by 1 unit. Yes, two things specific. Two things specific. One, object of unit mass and temperature change by unit. Temperature change by unit. So yes, this, why it is named specific heat capacity? Yes, because in this case mass and temperature, they are specific. Okay, you see, to change its temperature by 1 unit of unit mass. Okay, so yes, it is specific heat. What is definition? It is defined as the amount of heat per unit mass absorbed or rejected by substance to change its temperature by 1 unit. It depends on nature of substance and temperature. Yes, two things. Okay, what is this specific heat capacity? This specific heat capacity, C, is equal to heat capacity per unit mass. So what is its equation? C is equal to delta Q upon M delta T. C is equal to delta Q upon M delta T. Heat absorbed or rejected per unit mass per unit temperature. Per unit temperature. Clear? Yes, delta T, that is temperature. Okay, its unit is joule per kg per Kelvin. Simple. Okay, now if I make delta Q as object, then what is delta Q? So yes, delta Q is equal to, it is MC delta T. So what is meaning of this equation? If mass of object is M, specific heat of object is C, then to change its temperature by delta T, heat absorbed or rejected is delta Q. Simple. So this equation is used whenever there is change in temperature. Whenever there is change in temperature. Again, if you have mass M having specific heat C, then to change in temperature by delta T, what is heat supplied or rejected? It is delta Q. Delta Q is equal to MC delta T. So yes, delta Q stands for amount of heat absorbed or rejected by a substance of mass M when it undergoes a temperature change delta T. And yes, this equation is important, and this equation you have to remember for change in temperature. Yes, this equation is for change in temperature. For change in temperature. Clear? Okay. Now, here in this definition, C is equal to delta Q. Delta Q, that is heat supplied or rejected. M, that is mass, and it is delta T, means temperature. Here in definition we have unit mass. When this mass is replaced by moles, when this mass is replaced by moles, mass in kg is replaced by moles, then it is molar specific heat capacity. Okay, if amount of substance is specified in terms of moles mu instead of mass m, we can define heat capacity per mole. That is C is equal to delta Q upon mu delta T. And what is its unit? So see, delta Q means joule, mu mole, and delta T, that is Kelvin. Okay, so yes, it is one another definition. And yes, in case of molar specific heat capacity, there are again two cases. Okay, see, due to supply of heat, there is change in temperature. So we have to supply energy or we have to remove energy. So it is called process of heat transfer. It is called process of heat transfer. Whenever substance absorbs heat or it rejects heat, it is called process of heat transfer. So this heat transfer process can take place at some particular criteria. Okay, see what is, there are two cases actually. If the gas is held under constant pressure during heat transfer, then it is called molar specific heat capacity at constant pressure. Yes? Hello? Process same. Okay, we want to increase, we want to change its temperature, but during that process we have to keep pressure constant of given substance. For example, if you are given gas, then during the process of heat transfer, you have to maintain its pressure constant. Then it is called molar specific heat capacity at constant pressure, and it is denoted by Cp. Yes. Similarly, if the volume of gas is maintained during heat transfer, then it is called molar specific heat capacity at constant volume, and it is denoted by Cp. So definition is same. See, for specific heat capacity, molar specific heat capacity, Cp and Cv, there are only some minor changes. Here you have to write unit mass, here you have to write unit mole, here you have to add at constant pressure and at constant volume. Okay, so these 1, 2, 3, 4 and 5 definitions you have to remember. Okay, okay. Okay, now next topic is calorimetry. Okay, what is calorimetry? Before that we will see one definition, that is isolated system. Now what is meaning of isolated system? See, for example, it is object, okay, it is substance object under observation, under study, okay. Then object, substance or system of objects under thermal study, under thermodynamics is called system. So it is called system. Okay, what is surrounding this system? Properties of this system, they change due to its surrounding. So yes, which have direct effect on system, it is called surrounding. So yes, it is called its surrounding. It is called its surrounding. Okay, what is isolated system? If there is no exchange of or transfer of heat takes place between system and surrounding, then that system is called isolated system. No heat exchange, Q is equal to 0 between system and surrounding, then such system is called isolated system. Okay, a system is said to be isolated if no exchange or transfer of heat occurs between the system and its surrounding. Simple. Okay, if that system, if it is system, okay, and it is its surrounding. If system having parts, some parts, okay, suppose it is part A and it is part B. If temperature of part A is high and temperature of part B is lower, then heat transfers from part of high temperature to part of low temperature. Yes, heat transfers from A to B, not from system to surrounding. Yes, between parts of system. Okay, so whenever you are given one system having parts of different temperature, then heat transfer takes place between parts from high temperature to lower temperature, and as no heat transfer between system and surrounding means there is no loss of heat. No loss of heat means heat lost by one part is equal to heat gained by second part. Yes, heat lost by first part is equal to heat gained by second part. Okay, if you make or if you add hot water in ice, then what happens? Yes, ice, it absorbs heat, while hot water, it removes heat. So that heat gain and heat loss, they are equal in isolated system. So here what is statement? When different parts of isolated system are at different temperature, heat transfers from higher temperature part to lower temperature part, and this is most important relation that is used to solve questions. Okay, heat lost by part at higher temperature is equal to heat gained by part at lower temperature. Clear about this? Heat lost is equal to heat gain. Simple. Okay, yes. What is calorimetry? Calorimetry means measurement of heat, and a device in which measurement of heat can be made is called calorimeter. Is called calorimeter. Okay, now see, it is the method of measurement of heat. Okay, how to measure heat. See, what is construction of calorimeter? It consists of a metallic vessel and a stirrer of same material like copper or aluminium. Like this. It is supposed a vessel. Okay. Vessel is kept inside wooden jacket which contains heat insulating materials like glass wool. So around this vessel, that is insulating medium. Why insulating medium? Why insulating medium? Okay. If you place this insulating medium, then due to that no heat transfer between system and surrounding. Yes, it is called system. It is called system and it is called surrounding. So this wooden jacket behaves as shield. Behaves as shield. Clear about this? Okay. No transfer of heat takes place between system and surrounding. Between system and surrounding. There is an opening in outer jacket through which a mercury thermometer can be inserted in calorimeter like this. One opening like this, in which you can say, okay, yes, thermometer can be inserted in calorimeter. So with the help of that thermometer, you can measure its temperature. Means what is amount of heat. See, from temperature, yes, from temperature you can measure what is heat. Clear? So it is calorimetry. What is calorimetry principle? It is called calorimetry principle. Okay. Heat lost by part at higher temperature is equal to heat gained by part at lower temperature. Clear? Okay. So yes, it is principle of calorimetry. This is it for today.